The next type of integral that we're going to examine is an integral with powers of tan x and secant x, and the power of secant x, m, it must be even and positive. Okay, so let's look at an example. Here's our example, the integral of tangent to the minus 3/2 x times secant x to the power 4. Alright, so what we're going to do here is we're going to take off secant squared x. We're going to split this up. We're going to put a secant squared x next to the dx. And it's like what we saw with our other integrals. We want a derivative of a trig function next to the dx. Alright, so secant squared is the derivative of tangent. So we want the rest of the integral to be expressed in terms of tangent. And we're going to use, in order to do that, alright, we want, here we have tangent, here we want this secant squared expressed in terms of tangent so that we can do a u substitution and put u equal to tan x. So we're going to use another trig identity to convert this into an expression in tangent x. And here's the trig identity. You're probably familiar with this. Tan squared x plus 1 is equal to secant squared x. Okay. Alright, so this is tan squared x plus 1. So we'll replace secant squared x with this sum. And now we're ready to do our u substitution. U equal to tangent x, and du is secant squared x dx. So this u integral is u to the minus 3/2. And here we have tan squared plus 1, that's u squared plus 1. And this is du. Now let's multiply through to get a sum of powers of u. U to the minus 3/2 plus 4/2, that's u to the 1/2, plus u to the minus 3/2. And let's do our power rule. Okay, so that's equal to u to the 1/2 plus 2/2, that's u to the 3/2, divide by 3/2 or multiply by 2/3. U to the minus 3/2 plus 2/2, that's u to the minus 1/2, and divided by minus 1/2 or multiply by minus 2. And now let's replace u with tangent x. Tan x to the minus 1/2. Okay. And that's it, and we're done. This is the last type of trig integral that we'll be looking at in this section. And this sort of looks like the first type that we did. The first type required that either n or m be odd. So this time we're requiring that both n and m are both even positive. And we're going to be using a basic trig identity, or let's say two trig identities. Okay, the following: sine squared x is equal to 1/2 1 minus cos 2x, and cos squared x is equal to 1/2 1 plus cos 2x. These are sometimes called the half angle formulas because the angle on the left is half of the angle on the right. Okay, so let's look at an example. These are different. These would be quite different from what we did previously, different technique. All right, so here's our first one. Okay, let's look at the integral of sine squared x times cosine squared x dx. So what we're going to do is substitute using these two trig identities. All right, so we'll have this, basically this times this, and the 1/2 times the 1/2 is 1/4. I'll put that on the outside. All right, so here I'll have 1 minus cos 2x times 1 plus cos 2x dx. Okay, multiplying that out, we have 1 minus cos squared 2x dx. All right. Now, what do we do with this cos squared 2x? Okay, well, again, we're going to use that same trig identity, or a variation of it. All right, we're going to say, well, here's the variation. Cos squared 2x is equal to 1/2 1 plus cos 4x. All right, so remember this, whatever angle's on the left, this time it's 2x, is half of the angle on the right. Okay, so this is that same, or a variation on that identity. All right, so now let's do this substitution. So we have 1/4 the integral 1, and here we have minus 1/2 1 plus cos 4x dx. Okay, let's just simplify that a little bit. Here we have 1 minus 1 1/2 minus 1/2 cos 4x dx. Okay, 1 minus 1/2, that's 1/2. All right, so let's integrate this. Here's the 1/4 on the outside. Here we have 1/2. All right, integrating that, that's 1/2 x. All right, minus, all right, now we have to integrate cos 4x. Well, the derivative of sine 4x is cos 4x times 4. So we're missing that 4 on the outside, so we'll have to compensate by multiplying by 1/4. Okay, and that's a solution. Okay, the next type of integral appears to be the same as the previous one, but this time, instead of m being even, we require that n is odd and positive. Okay, so what we're going to do here, well, let's start. Well, let's look at an example. Okay, here we have the following: tan cubed x, so there's our odd exponent, and here we have secant to the minus 1/2 x dx. Okay, so we're going to put a derivative next to the dx, and this time we're going to put the derivative of secant x next to the dx. That's secant x tangent x. All right, so let's take off one tangent x from here, so we're left with tan squared x. All right, so we're going to have, again, next to the dx, we're going to have secant x tangent x. And where are we going to get the secant from? Well, we'll just change this exponent. Okay, so we have to change this exponent so that this secant x times whatever we have here is going to be equal to secant to the minus 1/2. Okay, so here we'll put secant minus 3/2 x, and we chose that because minus 3/2 plus 1, that's minus 3/2 plus 2/2, is equal to minus 1/2. All right, so we haven't changed the expression above. All right, so this is our du. And now that's the derivative of secant, and we want the rest of the integral to be expressed in terms of secant. So we're going to use the same trig identity we used in the last problem. We're going to use the fact that tan squared x plus 1 is secant squared x, that trig identity. Okay, so that means that tan squared x is equal to secant squared x minus 1. Just bring the 1 over to the other side. So this is secant squared x minus 1. So now we're ready to put u equal to secant x. And du is secant x tangent x dx. So we'll substitute in, we'll substitute secant x. We'll put u equal to secant x, and let's do that here. And so here we have u squared minus 1. And here we have u to the minus 3/2. And all this is du. All right, multiply out so we can get a sum of powers of u. All right, so here we have u to the 4/2 plus 3/2. So we have u to the 1/2 minus u to the minus 3/2. Okay. Use the power rule. Add 2 over 2, so we get 3/2. Divide by 3/2 or multiply by 2/3. And here we're going to add minus 3/2 plus 2 over 2 plus 2/2, so that's minus 1/2. Divide by minus 1/2 or multiply by minus 2. All right, now substitute back u equal to secant x. So we have 2 secant x to the minus 1/2. Okay, that's this. Plus 2/3. Now I'm substituting into here. Secant x to the 3/2. Okay, and that's our solution.